All right. Good morning, everybody, and welcome to day 4 of our Animus and San Juan Watersheds Week. By now, I imagine many of you know me, Mark Sheely here from NMWRRI, and I also imagine that many of you at this point are pretty familiar with how our webinar participation works, but for those of you who maybe aren't, I'll just give a brief overview. Many of you can see this as your window in viewing this webinar. To ask questions of our wonderful presenters today, you can use the Q&A button there. Also, we want to encourage asking questions orally to give a more dialogue feel to this webinar experience. So after a presentation, if you'd like to ask a question to one of our presenters, please use the hand raise function and we'll try to get to you. And lastly, for any other comments or questions that you may want to ask, if there's some technical issues or something else that comes up, we encourage you to use the chat function as well in this meeting. With that, I'll turn it over to today's MC, who has been a familiar presence throughout this this webinar series, as well as the conference series as a whole since its inception back in 2016. Dennis Mcquillan. Dennis has 37 years of professional experience in the environmental field, both as a regulator for the New Mexico Environment Department and as a consultant, educator, and freelance writer. His accomplishments include more than 200 site investigations, dozens of which received corrective action, such as the provision of safe drinking water service and cleanup of soil and water pollution. He's also launched new initiatives, including narrative and numerical standards for toxic organics in water, standardized rules for the abatement of water pollution, public education and outreach, free testing of domestic private water wells, a program to replace dangerous cesspools with modern septic systems at indigent households, rules to promote the safe household reuse of gray water, and research into regional environmental conditions and emerging issues, such as pharmaceutical residues in ambient water. So Dennis, I'll turn it over to you. Oh, I believe you're on mute.
Thank you, Mark, and good morning, ladies and gentlemen. We have 6 more really terrific speakers lined up for this technical session. You know, the talks have all been really good so far, and hats off to WRI on pulling this virtual field trip and virtual conference off. It's really been great. So let me also just point out that at the end of the technical presentations, Mark will be giving away some more swag. You've got to be present. There's 2 WRI coffee mugs, another copy of Kathy's book, 100 Years of Water Wars in New Mexico, and the grand prize, a day-long float trip down the Animas River, or San Juan, for next river season, generously provided by the Desert River Guides of Farmington. So our first speaker is Brandon Francis. Brandon was born and raised in Black Mesa, Arizona. Currently, he's a research lab tech at the NMSU Ag Science Center between Farmington and Shiprock. He researches and monitors the impact of the 2015 Gold King mine spill and the effect that that had on San Juan River agriculture. So Brandon, the floor is yours.
Having a little technical difficulties here. Okay. Give me 1 second. I don't know what happened to my screen. And what's going on with my PowerPoint. But yeah, te Shay Brandon William Francis in the share. Not or the net touchy ni ishle. The tutso ni bushes chin. Kitlachini e dash another turchini dash che. Shechina e tko baha. I that's how I identify myself when I'm introducing myself to a audience. And as a Navajo person, I like to establish kinship and get to know people, and anybody that's related to me, we identify with each other. And as I always like to tell people that when you're introducing yourself, Navajo people, they like to give long introductions, and they always like to identify what they do and how they're connected to the land. So I primarily identify myself as a corn planter, someone who plants corn, and I generally tell people that when I have a job to support this way of life. So I'm corn planter first, and then I also do research at the Agricultural Science Center where I'm sitting right now. And I love this new format that we have, even despite all the conditions that we're going in. And I like to tell stories about how I got here and how we got to this situation, and relay the farmers how they're feeling about the research that we're doing and the research that Agricultural Science Center is doing, but also everyone else is doing in the local community. And but before I get started, these are just some pictures that I've taken over the course of the 5 years since the Gold King mine spill, and it's all related to the work. And I'll be sharing the farmer's perspective and also how I got to this perspective, how this research has affected their perspective, as well as NMSU Agricultural Science Center's role in all of this. So if you have any questions regarding any of the pictures, feel free to ask. But first, I always like this quote by Mr. Rogers from Mr. Rogers' Neighborhood, and I think it's very poignant when he was this quote is when I was a boy and I would see scary things in the news, my mother would say to me, "Look for the helpers. You will always find people who are helping." And on that note, I like to thank the people, especially Dennis from the New Mexico Environment Department. He's always very helpful and has very good insight and technical knowledge on how we can conduct this research. And also the WRI for putting this on. And then the San Juan Soil and Water Conservation District, Melissa May, Andy, and Alyssa, they gave a very good they had a very good video that they put together and some very good presentations. And also the New Mexico University Extension, Bonnie Hopkins and her group down there has been very helpful. And Steve Austin from the Navajo Nation EPA, he's also been very helpful with his knowledge of their area and his years of expertise. And also the people from Socorro, the New Mexico Tech team, they always have good presentations and good advice when we talk to them in person and when they share their knowledge. And also the people from the USGS, Everett Oldham from the same office as the San Juan Water and Conservation District, who has years of knowledge of farmers in this area. And the NMSU team from April Olery to Barbara Hunter to Elise Matthews, who came in and shared a lot of her nutrition data. And because we were coming up with all this food, and we didn't know how much of the content was actually harmful to people. So when she shared that, and we shared that with the Navajo people, it was very helpful. And Sam Follin, who took over the irrigation ditch knowledge and shared it with a lot of people. And then Gaurav Jha, who was a major part in the long-term monitoring study. And Michael, who's doing his corn study. Michael Whiten, you saw his post the other day. And Dr. Weindorf from Texas Tech and his team, they're the ones that brought us in contact with the X-ray fluorescence spectrometry. And we are thankful for that. And Dr. Carletta Chief and her team from U of A, the Navajo Nation, the San Juan Farm Board, and all the chapters, Shiprock, Hogback, Nunazad, Upper Fruitland, San Juan chapter, they've all been helpful with letting us present and letting us talk to the people about our results, and because this is really the people's data, people's information, and they've always been helpful. The Net College and Fort Lewis College and Old Fort Lewis, they've been helpful, and my mentor, the late Dr. Larry Emerson, whose presence is always felt throughout these presentations, and who always wanted good things for people living along the river. And then also the late Gilbert Yazzie, who was always a person who was an advocate for the river and for the farmers, looking out for the health of the river. But in our current situation, just like in 2015, we are going through a new situation with COVID-19, and it's brought up new problems, and we're facing a new situation. But another quote I always like, and that's by Bruce Lee, and he always said that in the midst of chaos lies opportunity. Despite all the death and the constant fear of contamination or infection from the virus, we are seeing a resurgence in interest in agriculture. And so people are looking for plants, they're looking for knowledge. So a lot of that knowledge that we have, and the reason we're doing this is to make sure that things are safe for agriculture, things can return to the way that we are used to, the way we grew up, and the way that's this region, this valley has been historically used for, is for agriculture. So I always like to share stories, and especially about Navajo culture. And one story I like to share is the story of the warrior twins. And why I always share this is the importance of being warriors, and our concept of warriors just doesn't relate to warfare. So in Navajo mythology and in mythology throughout North America, they have a mythology of these warrior twins who in our culture were born to changing woman, or Sanadle, and she gave birth to twins who like in the Bible, she gave birth like a virgin birth. But as the children grew, they wanted to find out who their father was, but at this time there was these yetis, or giants, on the land who were plaguing the people, and they came in the form of many things, like many evils, and some of them would kill people and harm people. And so these warrior twins, they went to their father asking for help, and their father, the son, who they eventually found out was their father, gave them knowledge to destroy these evils that were plaguing man. But these evils that were plaguing man, they were also the children of the sun. So in a way, they couldn't destroy them. And when they destroyed them, they became landmarks or various features on the ground, on the earth, like Shiprock. You can see that was a monster a long time ago, but they would always come back. So the monsters, the giants, they made a pact with the warrior twins that if they left them in the ground and if they didn't disturb them, and that they wouldn't come back. So that's why Navajo people, a long time ago, they wouldn't disturb the earth. They didn't dig into the earth. And so when they would farm, they would actually farm with a planting stick to disturb the earth very little, honoring that pact that they made with these yetis and giants. So if they broke that pact, these evils would return. They would return and wreak havoc on the world again. So in that way, all the scientists and all the people helping along the river are modern day warriors, combating the return of evil upon the earth in the form of contamination, in the form of I saw a presentation about landfill leaking. So all the people here, you guys are modern day warriors and helping us combat these evils on the earth. And my interest in this came from when I was writing my thesis. I was writing my thesis on the history of the San Juan River Valley. And the river valley is huge. It includes the Animus, the La Plata, and the San Juan. And the area that over by the hospital, if you've been to Farmington before, right near that area is the area we call Twitka, or the Convergence. It's actually a very, very holy place, and it's very symbolic in our culture. So in the course of my studies and my research, and learning from not only archival research, but from traditional ecological knowledge and from storytelling, which is oral history, and going back into the old French and Spanish explorers that first came to this region, and looking into their journals about when they first came into contact with people in this region, and making note of how they conducted agriculture. And the French and Spanish explorers, they marveled at how well people were doing agriculture in this region, in such an arid region even back then. And they noted that in every wash and every bacul or every wash that was leading towards the river, it used to be filled with cornfields, with squash fields, beans, watermelon. There was so much growing here, and they marveled that despite the arid conditions and what seemed like poor soil quality, that people were actually thriving and growing here. And they also marveled at the people who seemed to be thriving, but later on, agriculture would fail here. And I always tell people that agriculture has failed here many times, and it's always due to an event, whether people are in constant conflict with each other or a climatic event. And in my thesis, the scientific part of it was dendrochronology. And as a lot of you know, dendrochronology is basically just tree ring dating. And in the tree rings, if you go back to the 13th and 11th century, there was the droughts that were 70 to 90 years long. And in our current conditions, we're also in another drought year. I know a lot of you got the email from the governor that said that we're in drought conditions right now. But imagine if this drought went on for 70 or 50 more years, would we be able to survive that? And the ancient Puebloan people, they went through two events like this very closely, and they could not survive it. So we can use that as an example. But when we were first coming into the region and started doing research here, as everyone else did, was on August 5th. And then if you see one of the pictures from the beginning, was, if you notice the Orange River, that was when my first visual of the river. And I'm sure a lot of people got that same visual, even from a different angle or from a different day. And it's shocking. And it shocked people worldwide. But as over the
Brandon, before you go any further, I just wanted to let you know that I have your presentation up here. So if you want to guide me through your slides that you'd like to share, I can advance forward. I just want to let you know, we're running a little behind now. So you have I would say about 5 to 7 minutes.
Okay.
Roughly. So
I have these slides on a 30-second timer.
Oh, okay.
It should end perfectly on time.
Okay. Can you see the screen right now? I just want to make sure that you can see which part of your presentation I'm showing. I see you're going.
Is it stuck on one video?
Let's see here. I think is this where you? I think maybe this is where you had had landed previously, talking about the images of the Yellow River?
Yeah.
Okay.
So our work basically, we on the reservation started on August 5th, and we came in and we started taking water samples just like everybody else, but everyone at the Agricultural Science Center, we're not hydrologists or anything like that, but so we were thinking up ideas and brainstorming ideas of how we could make an impact. So we came in contact with a lot of farmers along the river, and a lot of them, when we would pull up in a government vehicle, they would come to us and like, oh, I almost brought out my shotgun, you know, like, because they have this like distrust of government officials. But over time, we actually through constantly going back, because this project that we've been doing, has been going on for 5 years. So going back to these farmers, earning their trust, and because a lot of them, this also created a lot more mistrust with people along the river, but showing people that you can actually create camaraderie and going back to kinship, how we can create kinship with other farmers, and showing them that you're there, and showing them that there's entities out there that can actually help people. But there's still a little bit of mistrust about what's going on in the river. But having a constant presence in the community and showing people that we are there, and there's other groups helping, it's very, very what do you call it? It helps them with their well-being, because growing and planting along the river has been going on for centuries, and we want to help them, and it's good for people to be there to help. And I appreciate everyone's help. And if you have any questions, I know I planned for a 25-minute, but I re-looked at the schedule and it was a 20-minute presentation. So if you have any questions, feel free to ask.
Okay. If anybody has any other questions, Brandon, is there an email address that people can reach out to?
I can put it in the chat box.
Okay, yeah. Thank you so much. Thank you so much, Brandon.
Thank you, Brandon.
Hey, you're welcome.
You know, Brandon, I've just got to say your contributions to these conferences have been so wonderful all these years. You bring a really important perspective to the conference, and thanks again for sharing that with us. So our next speaker is Christine Osborn, who I've had the pleasure of working with for several years on the Wynn Act activity, and she's with the state of Utah Department of Environmental Quality, Division of Water Quality, and she's currently an environmental planner and a NEPA coordinator. She's also the communications and outreach coordinator for the San Juan Watershed Monitoring Program, which is this Wynn Act activity that involves 3 states, 3 tribes, and 3 regions of EPA. Prior to working with the Division of Water Quality, Christine worked as a content strategist and communication specialist in the Planning and Public Affairs Office, where she created website content, developed strategic and risk communication plans, worked with the water quality people on hazardous algae blooms, waterborne pathogens, PFAS monitoring, and she produced Utah's annual web-based State of the Environment report. I think it was last year. Those of you who attended the conference, Christine taught a workshop on communications. So Christine is going to tell us about Tell Your Story, turning watershed data into a compelling narrative. Christine?
Well, thanks. Let me make sure I've got this. Can you see my screen? I can't see it, so I'm not sure.
I can see it.
Okay, awesome. Well, thank you so much, Dennis, for your kind words, and I really love working with everybody, both with the conference and also the group that's working on the Wynn Act funding. And I feel like it's a real privilege to come after my presentation, to be after Brandon's, because a lot of what he spoke about relates directly to what I'm going to be talking about today with stories. I think as scientists, we often don't always consider the impact that stories have, but storytelling is really the most natural way for us to understand each other and to communicate information. And I think that's very clear from what Brandon was speaking about in his presentation. So if we think about stories, they're happening all the time, and they create and shape and transform our myths. Now, myths, we don't have to think of myths as fantasy necessarily. Myths are the way we make sense of the world. And so when we use stories to create and shape and transform our myths, we are using the stories to change the way we're viewing the world. And data provides us with the information that can create a better understanding of what is going on in our world. So before I start, there's a couple of little quotes I wanted to have everybody keep in mind that I found really useful when thinking about data and stories, because often we think of these as polar opposites, or a binary. There's data and there's stories, and the two will not mix, but they really go together, and it's really important to combine data with stories. Chip and Dan Heath, who wrote a book called Sticky, about how to keep ideas sticky, they said, data are summaries of thousands of stories. Tell a few of those stories to make the data meaningful. Another one is from Brent Dykes, who he works with Domo, and they do a lot of storytelling with marketing and business. And his quote is, people hear statistics, but they feel stories. And then finally, one of my favorite people, Brene Brown, who talks a lot about emotions and the human condition, but is very data driven, says maybe stories are just data with a soul. So keep that in mind. We'll go through the presentation and kind of talk about how you can make data something that people remember, and why stories are so important to what we're doing in the scientific community. So power of stories. If you think about it, our ancestors, at the end of the day, they would gather around the fire, probably eat dinner, talk about what had been going on in their day, what they had encountered. This was their way of telling their reality, exploring other people's reality, sharing information. What happened? What did they find? And the oral tradition is what we came out of. Writing is relatively recent, if you think about it. And the reason stories are so powerful are they have a really strong purpose. Stories that share knowledge and information. They're a way for us to communicate with each other about what we know and find out about what other people know. They're an opportunity for us to explore ideas and to challenge accepted wisdom. We can't grow in knowledge if we don't challenge it, and being able to talk with other people about it through stories is a safe and exciting way to look at knowledge in a different way. Make sense of a complex world. I think we're trying to do that right now with what's going on with COVID-19 and a lot of the things that they're happening around the world and around the country. And our stories are the way we put together the information that we have to try to understand what's going on. Stories are an opportunity for us to ask and answer questions. The storyteller will ask questions and answer questions, and the listeners do the same. It creates personal connections. If we have a shared story, that brings us together in ways that simple data does not. It supports our shared values and reinforces our shared values. It helps build collective understanding, how we see the world. And one of the most important things is it links the past, the present, and the future. So the stories that we tell now are looking back at our past, where we are currently, and what we want to have in the coming days. So here are 6 effective rules of effective storytelling. And one thing I just wanted to point out before I go too much farther is that I've been really amazed and impressed and proud of all the work that everybody here has been doing as far as storytelling and using data. So this may just be a refresher for a lot of you, because I see that the people in this watershed already know how to tell stories, and they already understand the importance of stories. So this is just kind of a refresher, but good stories tap into universal themes. Brandon's theme, when he was talking about the warriors, that's a universal theme. The hero's journey, is all our journeys. Respecting the earth, respecting each other's, those are universal themes that take place in stories. We don't often associate data with that, but really it is an integral part of that. When you're telling a story, you want to identify the purpose of the story and then create a clear structure. So what's the beginning, the middle, and the end? And sometimes the end is open-ended. You appeal to deep emotions. People relate better to information when it taps into that emotional framework. Offer something surprising and unexpected. Sometimes that's positive, sometimes that's negative, sometimes it's we don't really know, but you want to keep your listeners engaged with what it is that you're talking about. And stay simple and focused. Shaggy dog stories are entertaining for only so long, and we don't want to take our listeners down to dead ends or paths that take us away from the main object of our stories. So as scientists, I can look at this chart and go, wow, this is really cool. Great colors, look at all this information. So this is what scientists see. And this is what audiences often see. And it's not because they don't understand the data, it's because the data hasn't been framed in a way that makes it easy for people to grasp. So data without a story has some issues. It limits people's understanding. It lessens the impact and relevance. This was a spreadsheet that Division of Water Quality put together when we were doing sampling after the Gold King mine spill. And it's got a great amount of information, but to just look at it doesn't really tell people what they want to know. Is the water safe? So the data is important, but our job as scientists is to try to compile the data in a way that we can communicate with other people. If you've got too much data, there's information overload. People can only process 7 pieces of information at a time, and if you throw a lot of data at them, they're not going to be able to process it at all. Data without structure is a problem. A graph or a bar chart that provides some structure, but a story makes the data sticky. It dilutes the value of the story to the data to the listener. It impairs memory retention. Like I said, if there's only so much that we can hold in our brains at a particular time, then it's going to be very difficult for us to hold on to that data and what it means. And it also hampers clear decision making. Now, data with a story, I haven't even started my story or my data, and the picture I wanted to put was evocative, particularly for the people living in the watershed. Soil is life. If the soil is contaminated, people can't grow crops. The ecological health of the system is at risk. The water quality is at risk. There's so much that is contained in the story of the soil, but we need the data to explain what's going on. So data with a story provides a compelling narrative that is driven by the data. It creates scientific and emotional connections because science, it's emotional if you think about it. It's driven by curiosity. It's trying to solve problems. It's trying to help people. And so there is an emotional connection with the data that I think gets overlooked oftentimes when we get bogged down in numbers. The data with the story explores and explains the relevance of the data. What does it mean for people? And it builds a framework that improves mental processing. This is the whole idea of memory and being able to use data to make sense of what it is that we're concerned about and that we want to know about. And it turns metrics into actionable concepts. And I'll talk about that a little bit later. So data plus stories equals impact. So if you're telling a story, you want to begin with a question. When you set up your story, what is your audience going to learn from your story? And then you're going to end with an insight. If we can't leave something useful from the data, learn something useful from the data, then the story is really not worth telling. So you have to have the question and you have to have the insight. Take the audience on a memorable journey. Again, as I've been pointing out, memory is really important for retaining data. And so if the story isn't memorable, then the audience is going to be losing. You're going to lose them. And you want them to be part of what you're doing. No, this is really important. Know the audience and connect with their values. People understand what you're telling them if you have connected with them on a deep emotional level. Explain with visuals and narrate with words. People can understand the metrics, trends, and patterns better if you provide them with visuals, and then you use your words to give voice to these data. Provide context for the data, and be clear and concise. So, oh, and be honest and credible, which is also really important. It means have good data. So you're going to ask questions of yourself to get started. So what is the key message? As we were talking about before, if you're going to tell a story, you have to have a question or a message, something that you want to be getting across, something you want people to be focusing on, and something that you want to focus on. What do you want the audience to know or do with the data? Just handing them a bunch of information doesn't really help them make sense of what you're trying to say. How can you structure a narrative using the data? How can I visualize the data to communicate meaning? And there are lots of ways to visualize data. You want to be sure that however you're visualizing it adds to the story, doesn't detract from it. Which brings us to this. Is the data moving the story forward, or is it creating clutter? If the data doesn't move the story forward, please leave it out. Will the data help drive decisions? So data is something that's implementable, not something that you just look at and put in a drawer. What can you do with this data? So this is a story framework. You have the setting, the characters, and the conflict. And conflict, not necessarily, it could be just the issue or a concern. It doesn't have to be necessarily a conflict. And then your big idea, that's the key message that you're trying to get across. That's the what. And you're moving through the setting, the characters, and the conflict or issue to your big idea or your main message and your resolution and how the data got you to that resolution. And sometimes the data, it doesn't actually get you to a resolution. It just gets you to your next step. So what is the setting? We've got a huge setting here because we are a multi-jurisdictional watershed that moves. The setting goes from the headwaters of the upper Animus all the way down to Lake Powell. So the setting is a large land base and a large topography, and involves lots of different people with lots of different needs. So who is your audience? And what are their values? What's most important to them? And what are their stories? I think it's really important for us to understand the stories of the people that we are talking with, because their stories inform us in the stories we tell and also in the data that we gather. These are the people that live the land. They are on the ground. They are supported by this watershed. They love this watershed. They care about this watershed. Their stories reflect that care and love of the watershed. And that helps inform us as we are collecting data. You want to know what their hopes and concerns are. How can you present data if you don't understand what it is that they want to know? What can you tell them? So you're out collecting data, you're out on the river, you're doing sampling, you're looking for clues. There's lots of things that we're looking at right now. Metals in the water, nutrients, waterborne pathogens like E. coli. All of these impact the people who are living in the watershed and the integrity of the watershed. And how are you going to tell them this information? And these are just two examples, which is why I wanted to emphasize what a great job everybody has been doing in the watershed about telling their story. Our Animus is the Animas River Community Forum has done a terrific job of combining story with data. So if you've looked at the brochure or the story map, you see that they ask a question, is my water safe? And then they say what the data tell us. And then they say what you can do to keep yourself safe and what you can do to help your watershed. So this brochure is an excellent example of how a community group has looked at the audience, looked at the values, looked at the data, and combined it in a way that makes it usable and user-friendly and connects with the people on the ground and connects the data to what it is that they care about. And the other one is there have been a lot of concerns about whether or not the food is safe to eat. And the Buy Fresh, Buy Local Northwest New Mexico group has done a great job of promoting local food to help local families. And I'm hoping that that's still going on even with the COVID-19, because it's a great opportunity to say, yeah, we have looked at the data and we see that the food is safe to eat. And we're taking that data and we're putting it into action. And the action is we're getting the food to the people that need it, and we're getting the growers' products to the people who want it. And we are helping to spread the message that the food is safe to eat and that you can't do better than local. And so that is a way of taking the data and turning it into something that people can use and benefit from. Lastly, talk very quickly about visualization to support data. So if you're talking to a group of scientists, you may want to have data that's, or data visualization that's more complicated, but you can convey data in much simpler forms like infographics, dashboards, and story maps. Then you can move forward to interactive data presentations, filters, and analyses. These are the kinds of things that people want to dig a little bit deeper into. An issue can look at and see that your data supports what you're saying. Bar graphs, trend charts, scatter plots, correlation matrices, all of these are good ways of getting the data, visualizing the data. But remember, you don't want to visualize the data in a way that causes clutter or confusion. You want to visualize data in a way that supports the story and it supports your insights. So I'm just finishing up with the Lake Powell coring project, which I think is a pretty fascinating story. These scientists were out on a boat drilling cores in Lake Powell, and it's an important information because Lake Powell is an important recreation facility. There's plans to use Lake Powell water for municipal water supplies in southwestern Utah. And there's a lot that we want to know about metals deposition from the mining and the natural geology in the area. So these were the folks, these are people who were out for weeks at a time on a boat in the cold. They actually spent Thanksgiving on the boat doing core drilling. So they have a deep tie to what they're doing, to the land, and to the outcomes of their data. And so as scientists, I think it's really important for us to remember that we have a story to tell, and the people that we are telling the story to have stories to tell. And by communicating with each other and sharing our data in a way that is meaningful to all of us, we're going to be able to create connections and have a better understanding of what it is that we need to learn, we need to know, and how we can work together to improve the health of our watershed. And that's my presentation. Thank you so much for listening.
Thank you so much, Christine. To any of our attendees, if you'd like to ask a question of Christine, you can use the hand raise function, and myself or my colleague Jeanette Torres will allow you to speak. Let's see. And let's see, and if people would like to follow up with any questions that they may have later, Christine, is there an email address that you'd like to give out?
Yeah, it's C Osborn, COSBORNE @utah.gov, and I will type that into the chat window.
Okay, yeah. No, it doesn't look like we have any questions, but we do have one of our participants thanking you for your presentation. Professional interpretive naturalist for 13+ years, Andy Bleckinger. So,
thank you. I appreciate that.
Okay. Well, thank you so much, Christine.
Thank you. Appreciate you. You put me in the perfect spot. Following up Brandon couldn't have been better. So thank you.
All right.
Well, thank you, Christine. It's always wonderful to hear you speak about communications. So our next speaker will be Gaurav Jha, and he is currently a postdoctoral candidate at NMSU, although he's going to be defending his thesis on August 28th. And 2 weeks ago, he made a career change. He's now employed by Glorieta Geoscience in Santa Fe. But his research with NMSU had been on the long-term monitoring of contamination in soils, sediment, water, and plants caused by the Gold King mine spill. He's originally from the eastern part of India, from a place called Ranchi. Gaurav pursued an MS in soil science as a junior research fellow of Indian Council of Agricultural Research from Punjab Agricultural University in India, where his research focused on effects of salinity in vegetable crops, a part of the National Horticulture Mission in India. So Gaurav, you have the floor.
Thank you, Dennis. If anything sounds weird or if anything in my presentation does not look normal, please forgive me. I just got back. I've been doing field work, so I just got back and getting onto the presentation. And I'm pretty excited about this because, I mean, this has been like a very important project of for 3 years, and working on Gold King mine spill and presenting it. As the previous presenter mentioned about communication, that's what was the key part of this project and how it evolved. So, I mean, my project focused on monitoring of the metalloid contaminations in the Animus watershed agricultural system. Basically, we focused on the livestock consumption and also the crops that were important for human consumption. So, before I go ahead, so I would like to give you a brief background about how this project started and how it evolved into a long-term monitoring project. So after the Gold King mine spill on August 5th, 2015, the team from NMSU Ag Science Center jumped into the scenario and started collecting the irrigation sediments um, from the different irrigation ditches all across the watershed. Different samples were monitored using the portable X-ray fluorescence, which gave the results for the different metals of interest and metals of concerns in 90 seconds. During the time, 140 points were evaluated in 2 days, and some of the metals that were monitored included iron, copper, arsenic, and lead. What was found at the time was the riverbank sludge had the most concentration, followed by the irrigated soils and the non-irrigated soils of these metals. Lead in the sludge was found as high as 859 parts per million, and thus there was a need of monitoring on a long-term basis what was going on in the agricultural system across the region. So I'm going to highlight 3 different objectives of my project today. And initially, we started working on the irrigation ditches, and that became the 5-year-long project. So I'm going to mention about the nature and extent of the impact, what happened after the Gold King mine spill on the irrigation ditch sediments, how we sampled these irrigation ditches, and what were the results that we found. Followed by that, in my second objective, I'll be talking about the agricultural soils, mostly in the upper Animus River Valley, focusing on the 3 different agricultural fields that we monitored for 3 years and scanned at 4 different times during the period of 3 growing seasons. And the third objective, I'll be talking about, the spatial analysis, what we did, and how we found the hotspots of metalloids, and did some bioavailability of arsenic in that. Basically, what is the concentration that plants are uptaking. So 3 components I'll be discussing are irrigation ditch sediments, agricultural soils, and what's concerning to the plants. So this was the area that we studied for the period from 2015 to 2020 till today, till this year. And we started from Colorado, New Mexico border and studied all the 15 different irrigation ditch sites all the way into the Navajo Nation. So in the preliminary study that was done immediately after the spill happened, we found that there were we collected samples at every 2 feet in the irrigation ditch transects, and also for 3 different irrigation, 3 different depths in the irrigation ditch. So the results of the initial study were, there were no significant differences in total lead and arsenic concentrations between sampling points along the transects. And also, due to the decrease in metal concentration with depth, we found that it would be more valuable and to just, and monitor and collect the sample in the uppermost sampling depth. So what we decided to do for the long-term analysis was to collect samples only from the center and side of the irrigation ditch transects and only from the surface depth. So we collected samples at 4 different times. First sampling period for the long-term monitoring after the preliminary study started in February 2017. That was considered as the pre-growing season for 2017. And then we collected the post-growing 2017, which was after the growing season was complete in 2018. Followed by this, we had an interval of 1 year, and we collected the samples in December of next year, that is December 2018, and again after an interval of 2019. So you may see there was no sampling done between 2nd and 3rd sampling period and 3rd and 4th sampling period as pre-growing, because there's just 1 growing season. So we considered the 2nd sampling, the post-growing season, as pre-growing season for the following growing season. So we collected the samples at 4 different periods for the 3 growing seasons and did some acid digestion in the lab. We analyzed those samples in the ICP OES, which is inductively coupled plasma optical emission spectrometry, for 9 different heavy metals of concern. Arsenic we monitored in ICP MS separately, which is mass spectrometry. And the reason behind was the concentrations and the interferences that we observed in some of our results. All the statistical analysis was done and executed in SAS, and we compared our significant difference at a level of significance of 5%. So some of the initial results that we found was the center concentrations and the site concentrations. We found significant differences for almost for 8 different metals except manganese. There was no significant difference between the site and center elemental concentrations. When we compared these concentrations with the residential screening level, only arsenic concentration was higher than what was recommended as per the guidelines of New Mexico Environment Department. So we studied the significance differences for different growing time periods, and we found between the second and third growing season between 2017 and 2018, there were significant differences, and also between the first growing season and the last sampling season, there were significant changes, an increase in arsenic concentration. So we compared all the irrigation ditch sites. You see a lot of numbers here, but the red blocks shows the significant differences at 5% level of significance, and the green block shows non-significant differences. All the alphabets are the designation for the irrigation ditches on the on X and Y axis. In the top, we are not revealing the exact locations just to keep the identity of the farmers unrevealed. And so what we found, only one site was significantly differing with all the other irrigation ditch sites that we sampled throughout the Animas River watershed. And on closely monitoring that, we found the site was closest to the origin of the Gold King mine plume. And the maximum average total arsenic concentration we found was 12.73 parts per million. However, the range varies from 3.87 to 8.68 for other sites. So just going back to the map that I showed in the beginning, this site was closest to the Colorado-New Mexico border and was the first site that we monitored. So just getting back to the orange color of the water, we found some correlation, strong correlation coefficient of arsenic with calcium and iron. So iron and calcium coming by itself was not of main concern, but I mean, these metals are bound with metals like arsenic and lead, and that's what brings the concern of yellow color coming along with the river water. So when we found the higher concentration of arsenic in the irrigation ditch sediments, this led to the questions what's coming into the agricultural fields, because these fields are irrigated by the Animas River water and San Juan watershed for crops which are highly important like corn, squash, melons for the people, for the growers and buyers in the region. So we decided to monitor the agricultural fields. In total, we have monitored 9 different agricultural fields. However, I'm just showing 3 representative fields that we monitored for a long-term monitoring season. We used portable X-ray fluorescence, which gives results in 90 seconds. So we randomly sampled 175 points in the fields. So what we used to do, we randomized these in ArcGIS and fed these locations into the Garmin. We went to those points into the field and then scanned in a soil mode, which is one of the modes of VXRF, which gives the concentrations of elements in 90 seconds. We calibrated using the stainless steel alloy and standardized using the NIST standards, which are used to validate the instrument performance in the field. So in 90 seconds, we were able to get the concentrations of the metals of interest and metals of concern. And followed by that, we scanned, so I'll be discussing the results for arsenic, chromium, copper, and lead. Similar to irrigation ditch sediments, we scanned the fields at 4 different time periods, which was in 2017 pre-growing season, in 2018 post-growing, 2017 post-growing, 2018, and 2019 post-growing as well. Once we had all our data, we did some spatial and temporal analysis. For spatial analysis, we used interpolation by ordinary and indicator kriging in ArcGIS. I'll be presenting the indicator kriging just for the ease of understanding. Temporal analysis was done in SAS, and some of the statistical analysis and correlation analysis was done in Ars. So this slide shows a lot of numbers, but all I want you to focus is on the maximum concentration of arsenic in the agricultural field. So when we scanned the 175 points for different growing periods, we found for 3 different fields, which is represented by 1K, 3K, and 2S. These are just the representations that we use to designate the field and not reveal the identity. So these 3 fields showed the maximum concentrations, and most or all of them were higher than 7.07 parts per million. So there was a question how, or since we all know that soil is a heterogeneous system, how it was distributed in the soil. So we did some spatial variability and created some interpolation maps. So anything above 60% was of concern and was the concentration at 7.07 parts per million or higher than 7.07 parts per million. So this field was specifically irrigated under pivot irrigation, and what we found at the first sampling period and the last sampling period, there was resemblance in concentrations, and the concentration of arsenic reverted back. There was higher and lower concentrations at similar points after the growing period. We found similar trend for another field which was under pivot irrigation. So anything above 60% are above 7.07 parts per million and considered as the hotspots. If I'm referring as a hotspot, those are the regions of exceedances beyond 7.07 parts per million. Contrastingly, we monitored the field under furrow irrigation, and there was no specific trend for furrow irrigation, and the reason can be attributed to the fact that there is more leaching as well as movement of nutrients in the field under furrow irrigation as compared to that of the pivot irrigation. That was the spatial variability maps, but looking the temporal changes, what we found for chromium, there was an significant increase in concentration at the last growing period or the last sampling period, but the concentration of chromium was under the residential screening level. There was no significant changes in copper and lead. However, for arsenic, we found similar trend for pivot irrigations. There was an increase in the second in the post-growing 2017, and however, there was significant decrease between the first and the last sampling periods for all the 3 fields. So this, we found the higher concentrations of arsenic, or the hotspots, as I said, of arsenic, led to more questions. We presented these research results to the farmers all across the watershed. And in one of the teach-ins, there was a question what the plants are taking up. So we decided to monitor and analyze the soils, mostly for water-soluble and exchangeable fractions. And the reason behind monitoring only these fractions was because the bioavailable fractions, or the fraction that plants uptake, come under water-soluble and exchangeable fractions. So we picked up 2 agricultural fields where we found the soils that we brought into the lab exceeded in concentrations, and we scanned these fields as well for 75 different 75 sampling points. So in total, these 2 fields had 150 points together, following the similar method we used for the previous objective. But we collected the soil samples, and in the lab, we analyzed those using the Tessier's method, basically using DI water to measure the water-soluble fraction and magnesium chloride to analyze for exchangeable arsenic. We centrifuged at 6,000 revolutions per minute, and this was done for 30 minutes, and we filtered the supernatant and analyzed in ICP-MS. So talking about the total concentration, again, not looking into all these numbers, the only concern was the maximum concentration of arsenic in alfalfa and vegetable field that we focused. It was 8.6 and 11.3, again, more than 7.07 parts per million. So we also validated our portable X-ray fluorescence with the laboratory analyzed results. So we brought the samples, and even for other experiments, we collected 104 points during the period. And for 104 points, we found strong correlation coefficient for almost all the metals. The strongest was for calcium with 96%. Arsenic was giving 87% correlation. So all these numbers at least confirmed that we have the portable X-ray fluorescence that we are using for immediate analysis was performing well in the field. So these are the spatial maps of two fields that we were studying. But coming into, these are the hotspots of arsenic that we found in these fields. But coming into the results of water soluble and exchangeable arsenic, what we found was water soluble and exchangeable arsenic were much lower in fraction as compared to that of the total arsenic. So that was a good news that like plants are not taking up as, whatever the total amount of arsenic that's present in the soil. So we shared these results, but again, that was good for the scientific community, but in order to confirm these results and bring it out to the farming community, we actually collected the corns, pumpkin, melon, chili, squash, also alfalfa and pasture grass leaf tissue, and analyzed for the concentrations of different heavy metals. Specifically talking about arsenic, these metals were much lower than the limit that was 1.7 parts per million or milligram per kilogram. So we used different symbols like traffic lights just to let the farmers and people like the non-scientific community connect with the results what we were getting. So and the overall idea to have the spatial maps shows the color, which is easy to understand for the farmers. Where in the field they have hotspots or high concentrations of arsenic. So in a nutshell, as part of the emergency response, portable X-ray fluorescence was a rapid in situ and a non-destructive technique that we validated in the lab using the ICP analysis, and we also used NIST standards within the field, and that helps for site-specific determination of total concentration of metalloids of concern and interest in soils in a timely manner. So 8 out of 9 metalloids were higher on the sites for irrigation ditches as compared to the center sampling points that we found. So we monitored the field soils and higher arsenic total concentrations at some of the sampling locations in these irrigation ditches and fields across the watershed did not result in high bioavailable concentrations. So we have been sharing our research results since this project started, and all the objectives that we have been working on was part of communication and whatever the questions were risen up during the teaching presentations. So we shared through the radio panel, and I worked with Dr. Carletta Chief from University of Arizona and other members who are working, other researchers and members who are working in the region. So Brandon, Dr. Lombard, they've been sharing the research results with across the watershed with other groups. We had fact sheets that we shared with the farmers just because the written documentations are more helpful for them to understand. So that was all about my presentation, and I'm going to defend my thesis on August 28, which will have more research results. This will just submits that we worked on. But just acknowledging, definitely I have to acknowledge the farmers in Aztec, Farmington, and Navajo Nation who helped us to get into the fields whenever we wanted. My advisors, Dr. April Ullery and Dr. Kevin Lombard, who has been supporting to guide through the research results, and the lab support from Barbara Hunter, and also the grad student who is continuing to work in this project, Michael Whiting, monitoring the corn samples who presented yesterday. And undergrads who have been helpful in the lab. We collaborated on some of the projects with Texas Tech University and analysis with Indian Institute of Technology, Kharagpur in India. For outreach, we have been doing with Dr. Carletta Chief and Steve Austin. And this project was funded under the Wynn Act of EPA with NMED. So, I mean, that's all about my presentation. And with that, I stand for any questions. So if you have any questions, that's my email, and you can contact me through the email, and that's my website if you want to know more about the presentation.
Rob, I wanted to thank you for all the years of studies and work and papers you've contributed on this watershed and to this conference. And good luck on your thesis, dissertation defense. I'm sure you're going to do great.
Thank you, Dennis. And yeah, I would love if you all show up for my dissertation on August 28, and I'll share more results in there. Thank you.
So at this time, we're going to, Mark, are we going to take a 10-minute break?
We're running a little bit behind, so I would say maybe just a few minutes, maybe about 5 minutes, and then we can return back for our next set of presentations.
Okay, very good.
All right, thank you, everybody. You'll see you back here at, let's see, yeah, in about 5 minutes, 12:17.
Okay, well, it's 12:17, so let's get going with the second half of this session. So our next speaker is Dr. Kevin Lombard, and he's an associate professor of horticulture with the New Mexico State University Department of Plant and Environmental Sciences. He's also the superintendent of the NMSU Ag Science Center in Farmington, and that was featured in the virtual field trip that we had on Monday. For those who are on that, it's a 250-acre research farm that's part of the NMSU Ag Experiment System and is uniquely located on land leased from the sovereign Navajo Nation in northwestern New Mexico. And with his collaborators, Kevin evaluates specialty horticulture crops, arid land farming, and wise use of limited resources. He also examines the intersects between gardening and diabetes and cancer risk reduction and other human dimensional horticultural curiosities related to the needs of the mission of NMSU and to serve the agricultural community of the Navajo Nation and San Juan County and the state and the nation in general. I first met Kevin 5 years ago in the Emergency Operations Center of San Juan County, New Mexico, and immediately realized that he's not only a PhD technical expert, but he's also a farmer. So Kevin is going to be talking to us about revisiting composted biosolids as a fertilizer source and talking about the case of iron deficiency in hybrid poplar-based agroforestry in northwestern New Mexico. Kevin?
Okay, I'm going to try to make this work here. Thank you for the introduction, Dennis. I appreciate that. I don't know if you all can see my screen.
Yep.
Or not. Okay, you all can see it. All right. And so I was kind of interested in this topic, re-examining it after several years. The study that I'll be getting into some more specifics on. However, our interest here in agroforestry and nutrient recycling goes pretty far back, and it actually provided some of those technical knowledge or skills in heavy metals and how they're applied to land, and that gave us some good preparation for the Gold Team mine spill. So this was some of the work that that we've done over the last 20 over 20 years at the Science Center Farmington. I want to acknowledge my co-authors, Dr. April Laurie from Las Cruces main campus, Plant and Environmental Sciences, and Dr. Sam Allen, a colleague here at the Ag Science Center at Farmington, who's overseeing day-to-day work of the Poplar projects. So why is this project important? Why was the study important? Well, we've learned throughout this conference that nutrient runoff is a loss and a danger. It's a problem. Melissa May presented some E. coli and some results earlier in the conference, and so we have some nutrient runoff issues that's coming from a range of sources, including agricultural runoff, septic, and that kind of information. So the nutrient recycling does provide opportunities, though, for crops, because crops are nutrient feeders. They require 17 essential nutrients for growth and fruiting, plant survival. And so nutrients that are found in that can be reapplied or recycled are also an opportunity for us to look at biosolids. And how do we treat the soil is also a factor of why this research is important. We know that perennial plants require less tillage. There's opportunities for us to reduce carbon dioxide emissions through the use of woody perennials on the landscape. So I have to give some definitions. So composted biosolids, these are a byproduct of wastewater treatment plants. So basically what is flushed down the toilet is winding up in either septic tanks or municipal wastewater treatment plants for most of us. And we saw that with the run of toilet paper during the COVID-19 crisis. So I had to point that out, that we use about 80 gallons of water per day flushing. It's usually an afterthought. So some municipalities are taking these dewatered sewage sludge and turning them into something that might be useful because they're high in nutrients. And the municipalities are required now by law to either make the choice of either converting it to a useful fertilizer, incineration, or landfilling. So a lot of municipalities currently landfill a nutrient-rich resource that could be potentially used for crop production. And Albuquerque, I've got to point them out as a partner early in this project. This composted biosolids came from Albuquerque back in 2005, and they're producing a pretty high-grade composted biosolid that is a combination of yard waste and animal bedding. And you can actually purchase this for various uses, and they have it certified so that it can be actually applied to crops. Santa Fe is taking their wastewater treatment to another level. They're redoing their wastewater treatment plant, and they're essentially creating anaerobic digestion tanks where the methane gas can be recycled, used for energy, and then the composted biosolids can be reused and recycled to plants. So this is something that's strategies for us in the desert Southwest to also, conserve water and think about water precious resources, as we have to think about our waste, our own human waste. So what is the definition of agroforestry? Agroforestry is essentially placing woody perennial trees, shrubs on the agricultural landscape purposefully, or in utilization of topography, available land resources. But it's essentially a mixture of perennials and common agricultural crops. And it can be in clusters, like in a plot forestry. It can be in strips of trees, like what we see in this picture, intercropped with wheat. But it's a fairly common practice globally, and it's something that adds many different values to the agricultural landscape. So agroforestry can be incorporated for windbreaks. It's nothing new to the United States. We have lots of windbreaks in the Midwest. There's also usage for screening around different operations, for odor control around swine operations. So perennial crops are many different types of uses. And there's actually a National Agroforestry Center, and they actually provide, this is part of the United States Department of Agriculture, and they have quite a great resource. Their index, or their URL is up here, and it's a great source, and there's several great resources on the web if you just Google agroforestry. So how does that circle back to what we do here at NMSU Ag Science Center? We're utilizing populus or hybrid poplar in this particular model, and these are basically hybrids of different species of poplars, including our own deltoides, which is native to North America. And these are planted in blocks and over different time periods from 2002 to 2007. So we have different mature levels of plots, and also different schema of woody perennial plantings also around the farm. And we also started encountering this problem early on of iron chlorosis in some of the plots, and so this is a function of high pH soils, which dominate our soil chemistry here. And that has an effect of basically making micronutrients like iron here. As the soil pH increases, these micronutrients availability to plants become less able, and that's where we start seeing micronutrient deficiencies in certain trees, including fruit trees. So that's what got us thinking about composted biosolids, because they are high in iron, and this is part of the treatment plant that involves a process of removing phosphorus from the waste stream before water is discharged back into the Rio Grande River. And these are, composted and heated, and they're certified to be very clean and low in heavy metals and pathogens. And there's actually laws that are required for land application of biosolids to land. This is the EPA. They have the Part 503 rule, which is the fairly definitive rule on how much heavy metal loading can be done on ag lands with a given amount of in-sewage sludge or biosolids. And so there's a whole list of these 503 rules, compliance and pollutant load limits and whatnot. So these are important aspects for land application of biosolids, which we took into consideration. We came up with an application rate of 10 and 20 tons per acre, which is something that you would commonly use for cow manure. And when you looked at these biosolids, you looked at their chemistry, and right off the bat, you see that they're high in iron, which is right here, 476 parts per million, in all these micronutrients, and also high in nitrogen. And plants need a lot of nitrogen. So these hybrid poplars are very fast growing, temperate woody perennial crop. After 3 years, they look like something like that, which is a pretty substantially sized tree. We were measuring chlorosis using handheld devices, and we were taking measurements with tree measurements like you would in a forestry setting. And this is Dr. Sam Allen, by the way. He's doing the clinometer there. And then we would take measurements with the clinometer and use that to calculate growth parameters, how big these trees are becoming. And just in a nutshell, to break this down, the growth after just 2 years after the biosolid plots had been treated, we had substantial significant growth in all wood growing parameters of height and wood volume, which these are important parameters if you're looking to saw the log and use it for some kind of end market in forestry. So the take-home message was that the biosolids did improve growth parameters for the first two to 3 years. Now this is what the growth curves look like today. The important thing is just to notice that they start out very fast, they start growing, and then they're starting to slow down a little bit. The wood volume, as I mentioned on this bottom graph here, we do see that there's really no difference between the treatments now as opposed to the control plots that received no treatments. So the take-home messages on this is that, do we need to keep applying some type of organic fertilizer to these plots? Probably so, to keep them, growing more productively. A one-time application will give a kickstart, though, to new plantations, new established plantations. So we also did observe that we did have the highest SPAD values, which indicated that the composted biosolids were achieving the objectives of alleviating iron chlorosis. So this is important, and they were consuming residual micronutrients found in the biosolids. The salinity was minimal. The heavy metals were either non-detected or did not increase beyond the controls. And some other additional questions however, have been raised, and I'll get into those in a little bit. But just to show you real quick, like the lead levels here, these are the EPA rules for ag land, the threshold limits, and these were the limits of the lead in the biosolid treated plots. The control right here, there's no differences between what was treated and what wasn't for the heavy metal lead. Salinity increased a little bit. This would be the one main factor of applying any manure, not just composted biosolids. So any manure will have salts in it. Knowing what those salts are is really important before you land apply them. And so today, roughly a quarter of the plots are over 100 feet tall. This is pretty remarkable for just 14 years of growth. And the saw log potential, the wood product capability of these trees is pretty good, with a 15-inch diameter breast height. So that's 15-inch diameter, basically below where your eye level is. So there is some promise for this type of tree rotation, and in a possible schema with land application of biosolids. As I mentioned, we did not see any increases of the heavy metals in the soils. The SPAD measurements showed that iron chlorosis was corrected, and that there's more room for additional studying, and that these types of schema are not only important for like farm forestry, but for riparian buffer strips, windbreaks, wildlife habitat, and soil conservation. We're using these trees have been deployed for phytoremediation at an old refinery. So Dr. Sam Allen and our team are taking some analysis of these old studies, and we're compiling them now into a single report. And we hope to have all the popular studies wrapped up here for publication very soon. Carbon sequestration is obviously the big factor in environmental parameters that we really need to look at. How do we increase woody perennials on the farm forestry landscape? Potential challenges of biosolids are obviously emerging contaminants. If you do a Google search on biosolids today, you get a little bit of a mixture of opinions on them. There's our persistent organics and estrogen-like compounds and anything else that usually winds up in the wastewater stream. And so it's really kind of boiling down to educating the general public on what should be flushed down the toilet, I think, more than anything. And as municipalities are moving really forward in advancing, trying to get to capture as much nutrients as possible in recycling scheme and utilizing those captured nutrients to beneficial use. This is going to be an objective of a lot of different wastewater treatment facilities up and down the Rio Grande River and the San Juan River as well. And we're already seeing it in Durango, we're seeing it in Albuquerque, it's seen in Las Cruces. El Paso is definitely, they're desalinizing water now, and they're actually bringing water into the drinking water, potable water that's been ultra treated. So it's definitely on the forefront of a lot of waste engineers. But we need to understand what it means to apply these to land, and we need to make sure that the benefits don't exceed the risks. And just I mentioned some of these other applications of why woody perennials are important on the agricultural landscape. However, the end markets always must be considered if we're looking into some kind of end use, post-harvest use. Can we truck these products out, or can we mill them locally, thus reducing our carbon footprint, you know, if we don't have to truck things out too far. So just some references on where this literature is coming from, our mission and where the tree plots are located today. We have several plots, as I mentioned, in different stages of maturity and being harvested and still evaluated. So I'd like to thank other participants along the way of this multi-year studies, including lots of students and interns. They would have made lots of contributions to this study. I just have to end with that. And for any students that are listening to this presentation and you're interested in ag, there's a whole realm of possibilities at all the major great institutions in New Mexico. And so talk to your career counselor about those opportunities. Yes, let me try to do that. I'll just send it out during the next presentation. How about that? Can I do
All
that?
right. Sounds great.
Just
Thank you so
fumbling
much.
around with the, yeah, thank you. Thank you all.
Thank you, Kevin, and thanks again for all your years of research and contributions on this watershed and to the Agricultural Society. So our next speaker is Thomas Laurie, and Tom has more than 25 years of experience in numerical modeling of natural and man-made hydrogeological systems, development of integrated decision support models, and system dynamics modeling. His research focus is the development of new algorithms for simulating integrated water and energy problems that involve environmental impacts, power generation, climate change, and water resource allocation concerns. And today, Tom is going to talk to us about assessing risk to water resources from oil and gas activities in the San Juan Basin. Tom?
Okay, thanks. Let's see if this is gonna. There we go. So first off, I want to, thank everybody for putting this together. I know it's unusual times, and I'm, over the course of the week, it's been quite encouraging to see how we've been able to make this work over a virtual conference. So it's been terrific and really interesting to this point. But so what I'm going to talk about is a project. This is ongoing. We gave a talk about this last year. We were hoping to have more results at this point. We've made really good progress on the project, but in terms of numerical results, we've been kind of cut off from the quarantine issue and the COVID-19 stuff. But the first thing I want to do is talk about our project team. So I'm just a small part of this. We've got Owen Lofton, Tricia Johnson, and Dale Bowman, who really lead our field and sampling work. Also Whitney Thomas of the Bureau of Land Management in Farmington and her team, who have been just terrific to work with and really, really fun to work with also. Dave Harrell from the BLM Santa Fe, who's the kind of the overseer project manager on this. Kudos to all of them. So what I'm going to do is I'm going to talk a little bit about the motivation for this project. It centers around some reports called the focus on the reasonable foreseeable development of oil and gas resources in the area, and really kind of focus on the approach that we're using, the status, and then to be completed. And as I mentioned, this is going to be more a talk that's high on process and not so much on results yet at this point, but I still think it's going to be interesting, or hopefully. So our motivation, this is actually a follow-on project that we did, a similar project down in the Permian Basin. And once that was completed, the BLM wanted to look at the San Juan Basin with the same concern that there was increase in the drilling activity and hydraulic fracturing and so on. and that there could be additional stresses on the water and water resources in the area. And so they wanted to make sure that they weren't going to run into any unintended local impacts from both water shortages and even a water quality standpoint. So our approach was kind of a multidisciplinary approach to look at these cumulative impacts. So it involves data collection, both existing data and also our own data collection, field verification of water wells and wells in the area, field testing and monitoring, and then another task that were designated as geologic tagging. And I'll talk about each one of these in a little bit more detail. But let's see if we can get the pointer working here. I don't think anybody on this phone call is probably familiar with where the San Juan Basin is. Our study area is limited to the state of New Mexico. And what this map is showing is essentially the land ownership with the New Mexico Office of State Engineer water well database on top of that. And a few things to point out. So here's Navajo Reservoir, and most of the wells along the San Juan system, the Animus here in the La Plata and elsewhere. These are mainly, this has been shown in previous presentations this week, that they're mainly shallow alluvial aquifers. We're not focusing on those type of wells at this point. We're looking more out where the oil and gas activities are occurring. But we'll start with this database. So for the data collection and verification, the idea is to inventory the water, the users, the water sources, really around the areas of high and medium potential of oil and gas extraction. Also identify any past studies or tests that might pertain to any other conditions in the basin. Do a verification process where we actually work with the well owners to hopefully access their wells, sample the water in the well, and do some other measurements. And then also the field testing and sampling to measure and verify, so we get the GPS coordinates, elevation, well diameter, depth of water, total depth, things like that. And it's amazing how different some of these measurements end up being that we find in the OSC database. So a lot of times these things get logged in and they're not necessarily correct. Again, we're also doing the water quality sampling. I'll talk a little bit about more of that later also. And then the final step is to identify the candidate wells where we want to put in some long-term monitoring. So we're hopefully, the kind of endpoint of this would be to have a system of 8, 10, or 12 wells that we would be monitoring long-term for water levels. But really the key to this whole thing, or I should say the objective of this whole thing, is to establish the current baseline from which the future changes can be compared. And so without this baseline, we can't tell what's changing over time. And that's the importance of both the current sampling now, as well as the long-term monitoring. So there's a number of studies that have looked at the reasonable foreseeable development in the area. The one that we focused on for this project was the one by Thomas Engler, and it came out in January 2015. There's been a more recent one by Crocker and Glover with BLM. But the idea of both of these is to really look at what the known and potential resources are and where they expect them to grow into the future. And they both look at what the development might look like over the next 20 years. In addition, more recently than that, the BLM has put together a New Mexico water support document where they're looking at different water uses, water demands in the area, and within that they look at water for fracking in the area also. So, and again, we'll talk a little bit more about that. So some stats and figures. So the area is large. It consists of San Juan, Rio Arriba, Sandoval, and McKinley counties, about 4.2 million acres across that area. Of that, about half, 2.1 million acres, are federal land, and of that federal land, about 92% of that is BLM land. So the BLM is a major player in the area for providing leases for oil and gas extraction. Of that 2.1 million acres, about 1.8 million are leased for extraction and about 300,000 are unleased. Outside of the federal lands, there's also 1.4 million acres of allotted and tribal lands, and then another 700,000 of state or privately owned land. So by far, well, I shouldn't say by far, but by a large percentage, the land is federal, but there is quite a patchwork of land ownership, which has some issues with the field work that we're doing. But out of the regional foreseeable development reports, the baseline scenario is predicting about 3,200 new wells in the next 20 years. About 2,300 of those are horizontal wells that will require water for fracking. Within those reports, they reference a value of 3.13 acre feet per well for the fracking. The work that the BLM had done using the Frac Focus data. It's a website that you can go look and essentially they're logging the chemicals and the amount of water they use for fracking. So backing some numbers out of there, they came out with a number a little bit higher, about 4.8 acre feet per well, which means that over the next 20 years, we're going to need about 2.5 to 3.8 billion gallons of water for these wells to go in. So that might sound like a lot, and in some respects it really is, but on other respects it represents about maybe 5 to 6 days of the average flow in the San Juan River below Navajo Dam. So over the next 20 years, they would be using that much water for the fracking. So let's see if I can move something here. There we go. Okay. So back to the reasonable foreseeable development. So to help cull down our study area, we focused on areas that had high gas potential, mainly here in the Mesa Verde pool. And then also the areas of medium to high potential for the oil extraction, which is mainly in the Mako Shale down in these light blue and green areas. So if we start again going back to this map, we began with the New Mexico State Engineer Wells database, and from there we mapped that onto these areas, and we came up, I forget the exact number, somewhere in the order of 120 different wells that we were looking at, and the idea was to go out and visit each one of these wells to see what their status were and see if we could get measurements out of them. So we began that process, I want to say May or April last year. Since that point, we've been able to visit 45 wells. And you'll notice that between the previous slide and this next one, that there's actually some additional wells that show up. And that's from two reasons. One is the BLM had some wells that were not in the state engineers database that they wanted visited. And also just driving around, the field team found wells that weren't in anybody's database, and they would stop and see what kind of measurements they could get and try and document those wells. So from there, if we look at the ones we visited, there's a number of different land ownerships. The yellow is the BLM land, the light blue are the tribal and allotment areas, and then the green is the state lands. One thing that we try and do with this is work closely with the well owner. So with the BLM lands, it's a little simpler because we do have, it's their project and we have access to those wells. But for working with the private owners and the Navajo Nation, what we try and do is provide some value back to them. So when we go visit their well, you know, we give them all the information. They get a free water quality sample report. And we also photograph and try and get some pictures of the condition of the well that they can then use sort of as their own baseline for future analyses. In the time that we've been doing this, we also were able to get 4 water quality samples. And that's going to ramp up once we can get back into the field again. We're looking at you know, your basic cation, anion balance, and other water quality indicators. And then also we're looking at 2 different tests that give us traces of diesel or motor oil or gasoline in the system. Right now, out of those 4, everything is showing up as it should. Like I said, these were some of the results we were hoping to share right now, but because we had to pull out of the field in March, we haven't been able to get any more water quality samples. So I thought it might be interesting to just show people what types of conditions we're running into out there. So these are literally the photos that were taken during the field testing, as well as the field notes from the people that are out doing it. This is a picture of Owen Lofton here at one of the wells. I believe this is actually the Blanco Trading Post well. And so in his notes, he says it's a commercial well that was actively pumping. A truck was loading water nearby. And in this case, we were able to get permission from the owner to go ahead and sample the well. And again, if you go back to this slide, this is the well we're talking about, and indeed we did get some water samples out of there. But not all those wells are, not all the wells are that easy to get into. So this was a well that obviously has not been accessed for a while. It had a metal plate welded on top. Fortunately, it wasn't a solid well, and they were able to bend back that plate a little bit and get some instrumentation down in there. And we got a depth to water measurement of 663 feet and a total depth on the well of 1,000 feet. And those measurements are important because they're going to help drive, for instance, you can see the cable length recommendation. As we order supplies for the long-term monitoring, we have an idea that of the wells that we choose, how much supplies we need to order, but it also helps with the geotagging, which I'll talk about later, but that'll help us determine which formation we're pulling some of the water's coming out of. And again, there's other complications. So this is a well that had a pump installed into it, but there was no generator there. So one option that we could do with permission of the BLM would be to drill a hole into the covering plate. We could get some instrumentation down there to get things like the depth of water and the total depth. But to get a water quality sample, we would need to plug a generator into that pump, and so we could pump the water out of it and get the sample. But again, the idea is we don't want to disrupt the operations of the people who are using the well. So that's why we're sort of doing this in 2 levels of reconnaissance, so that we can look back and say, okay, this might be a well we really do want to go back and sample. So let's go talk to the rancher and figure out how we can do that. And then finally, I mentioned some of the, kind of the wells of opportunity that we drive by and just happen to find. This was an abandoned windmill, and it was just an open hole. So in the lower picture, you can see the hole here. In the upper picture is a shot looking into the hole, and you can see the casing below ground here with a big rock that stopped it up. They did it. We were able to get a depth to water of about 24 feet there. We don't know how deep this well is, but again, it could be something that might be useful for monitoring in the future. And then finally, I talked a little bit about the geologic tagging. So the idea with this is to, once we collect this data, hopefully we'll have depth to water, we'll have total depth on the wells, and we'll have some water chemistry that we can use. And the idea would be able to correlate these types of things to be able to tell us what the source formation are for these wells. From that, we can conduct a 2D layered kind of visualization model of the source waters. And again, that's to help the BLM provide you know, a basis for looking at water quality issues. If red flags start showing up, they can quickly identify what formation these waters are coming out of, and hopefully avoid any serious issues. So for yet to do, we want to get back in the field. This is really a field project, and hopefully we'll be able to start up again within the next month or two, finish the reconnaissance, especially the state and tribal and allotment wells. Those are probably the last set that we're really put into the database, complete the water quality sampling. And then again, the second round of the reconnaissance will be to identify the wells for the long-term monitoring. And that's going to be based on the well condition. You know, we want to make sure it's easy to get instrumentation down into there. Also access to the wells. So, you know, it doesn't necessarily have to be right next to the road, but, you know, we also at the same time don't want to have to drive 3 hours down a dirt road to go find a well every time we need to download the data. And then also the location, so both vertically and horizontally. So in other words, we wouldn't want 2 wells right next to each other out of the same formation. So we want to make sure that we're getting a nice diverse spread of these wells that we're sampling. Traditionally, we've done 15-minute sampling intervals, and we go out and we download them quarterly. And then the other final 2 steps is once we get the reconnaissance done, would be to create the stack visualization for the water sources, and then also a data repository, and there'll be a final report. And then finally, I want to make sure that I point out that there are some other studies out here. We've been working with Ben Linoff at the USGS, and he's doing a study around Chaco Canyon. This is a map of his progress to date there. And so we've been sharing data and trying to support each other in the work that we're both doing there. Again, I also mentioned the state of New Mexico has been very supportive of our work here and allowing us to access the wells on their land as well as the Navajo Nation.
Thanks again, Tom.
Yeah, thank you, Tom. That was very, very informative and also very timely. This talk that Tom just gave and the one that Mike is going to do, because the Bureau of Land Management and the Bureau of Indian Affairs have a draft environmental impact statement and resource management plan that is out for public comment right now for the Four Corners area. Comments are due by September 25th. The deadline was extended because of COVID. I will post the link to these documents in the chat box during Mike's talk. So our next and final speaker is Mike Hightower, who is a research professor at the UNM Center for Water and the Environment, and he's the program director for the New Mexico Produced Water Research Consortium, which we at NMED are a partner of. Mike's a technical consultant to Sandia National Labs in the areas of water treatment, desalination, and energy and infrastructure resiliency research, where he worked for 38 years. His focus in the past 2 decades has been in the development of innovative distributed energy water and energy technologies to improve critical infrastructure and natural resource security, resiliency, and sustainability. Mike's going to talk to us about produced water reuse opportunities and challenges in the San Juan Basin. Mike?
Okay, I hope that I'm unmuted. I think I am, and I think if I share my screen, good. I think that this is going to work. Here we go. Okay. So I've got a short presentation. I think I'm the last one for the whole webinar series, and probably this is a good idea in the sense that this is something that's emerging. This is a new activity coordinated between New Mexico State and the New Mexico Environment Department based upon House Bill 546 from last year. So this is a new effort. it will tie in with the work that Tom is doing in Northwest New Mexico, and some of the work that Tom has been doing in the Permian Basin in southeastern New Mexico. So the real focus around this is produced water reuse. There are new initiatives out of the US EPA that New Mexico is working on and to help lead the country in this concept of how can we utilize produced water for beneficial uses, both inside oil and gas and outside oil and gas. The work that I'm doing specifically is on the use of treated produced water outside the oil and gas. So let me just, you've been asking for people's contact information. Here's my phone number and my email address if anyone wants to get a hold of me. And happy to have you call me or send me an email.
Just a second before you continue, Mike, it looks like we're seeing your presentation in the presenter mode. I wonder if you could try swapping displays using the options there.
Okay, let me, I'll end the slideshow. Okay. And what do you want me to put it into?
Let's see here. Try going into just the slideshow mode again.
This one here? No.
Oh,
the true
that one right there.
slideshow? Yeah, that's what I thought I had it in.
Okay, it was, but I think you just have to change the view settings within there. So if you click the slideshow option again.
Okay, I did.
Okay. And up in the corner, if you see because what I'm seeing right now is the presenter view, so it's showing like the kind of the sequence of slides. If
yeah, I'm seeing the whole. I'm seeing a single slide right now.
Oh.
Okay. Tell me how I do that, and I'll do it differently. I apologize. I thought I had it.
That's okay. I wonder if our NMWRI tech could weigh in. I know this is an issue sometimes if you're using dual display to share something. I don't know, Andrew, is there anything you can think of to?
Okay, so hold on. So right there, go ahead on the bottom right. So hit the, yep, go ahead, right there. And then, so use the slideshow, hit that.
Where's that?
And the upper part of the bar.
I don't see my bar.
Oh, you don't see that? You don't see the?
No, I don't.
Okay. Let's see if I can request control. I can help out.
Okay.
Did you get that notification?
Probably not if I'm not.
Let's see.
So it worked last week when we were playing around with it.
Yeah.
My God.
So exit out of the share screen.
Okay, I'm trying to get down there to, it doesn't seem to want to do that now. I can't find the.
Hit the escape key.
Alrighty. Now, it doesn't like escape either.
So Control Alt Delete.
Jiminy Christmas.
Or if you'd like, Mike, I can share your presentation from my computer, and you can just
do that.
All right, sounds good.
Let's do that.
Alrighty. Okay.
Okay. Let's see. All right. Okay, can everyone see that?
I should just let you talk and you can do presentations. Okay, let's start real quickly. I'll try to catch up here. Sorry about that. I thought I had it worked out. I was seeing everything perfectly on my screen. Apologize for that. One of the things that's driving the whole discussion around the use and reuse of non-traditional water resources is some of the climate change issues that we're seeing. This data is from the University of Arizona. It came out about 10 years ago. And if you follow the science literature, in the last couple of years, people are really quoting this work on tree ring data. And a lot of them are looking at it to identify, lengths of droughts and are coming up with the terms of, 30-year droughts and things like that. I looked at that data about 10 years ago a lot differently. I did 50-year averaging to look at, is there any trends that you could see in the data? And what I found is that in the Southwest and in these mid-latitude areas, we go through these arid cycles and these wet cycles, and they're pretty consistent. Sometimes they're not quite as wet, sometimes they're not quite as arid, but I plotted it up over the last 2,000 years, and what we see here is that we're in the Southwest and in the mid-latitudes across the globe. That includes Australia and the Southern Hemisphere and South Africa and Argentina and Chile and parts of the Amazon, and in the Northern Hemispheres, India, China, and parts of Southern Africa or Northern Africa. The point is that we're in probably the worst arid cycle that we've seen in the last 2,000 years. And if you look at the trends that started in about 1875, 1850, 1890, somewhere in that range. So we're 130 years into this large scale droughts, arid cycle, if you will. And so we've got another 50 to 100 years before we start moving out of it. And I think that is beginning to hamper water resource issues and management across the globe. And so I think what we're seeing is that these large arid cycles, I've shown on this particular slide, that there have been major abandonments that we know about, the Anasazi and the Mayans and Angkor Wat. And if you go back, Rome and Petra and Jordan, and those areas are all during these very, very long arid cycles. So there are issues here. And so as people look at freshwater availability, and can I go to the next slide? Can I do that, or do you have to do that? You probably have to do it, right? Or okay.
Yep.
If you'll just go to the next slide. You're seeing a lot of interest in looking at what I call non-traditional water resources, whether that's wastewater reuse, agricultural reuse, industrial water reuse to supplement freshwater supplies. And so we've had our major drought. We've been in a major drought since about 2000. And so you can see in New Mexico, we've started looking at these issues of how do you take non-traditional water resources, in this case, specifically produced water, and utilize that for beneficial uses. So we started with Los Alamos and Sandia in the early 2000s. Recently, NMED and Office of State Engineer and the EPA have worked on a joint activity looking at how to look at the regulations around the beneficial reuse of produced water. We've had a conference through New Mexico Environment, through the New Mexico Tech and the New Mexico Desal Association on reuse of produced water. And then out of the Groundwater Protection Council, which is an element of the EPA, most recently is a produced water report on research directions for the reuse of produced water. So next slide. So that's kind of the work that's been done in New Mexico and in the Southwest around produced water specifically as a non-traditional water resource. But if you look at what the EPA's been doing for the last 6 or 7 years, based on work by the GAO, which is on the left there, looking at freshwater availability across the United States, you can see that it's just not the Southwest US anymore that is looking at both local, regional, and even statewide water stress. There are states all across the country that are seeing limitations on fresh water supply availability. So the drivers behind the GAO report was to talk to the federal agencies about addressing this shortage of fresh water and to look at other options and alternatives. And the EPA has done that. They've been taking the data and looking out, and a brand new water reuse action plan came out from the EPA in September 2019, and the final plan, that was the draft, the final plan came out in February. All of it around how do we create additional water supplies to supplement fresh water. So next slide will show that, if you can get to that. Maybe they can't. I'll try it myself. Okay. I can't control it. You've got to control. So the next slide. You'll see that the EPA draft report on the water reuse action plan includes looking at oil and gas produced water. So because New Mexico has been working with EPA on that and with the Groundwater Protection Council for the last 3 or 4 years, the EPA has asked the state of New Mexico to kind of lead that activity with the Groundwater Protection Council on the reuse of oil and gas produced water for beneficial uses, specifically outside oil and gas. And that's because of the recent House Bill 546, which is in the next slide, if you can go to that. You want me to? And which came out in 2019. That reauthorized or changed the authorization for the reuse of produced water. And so for reuse inside oil and gas, jurisdiction and regulations remain under the Oil Conservation Division, and reuse outside oil and gas was designated to the New Mexico Environment Department. So that act encourages enhancing the freshwater sustainability by reducing or eliminating freshwater use in oil and gas sector, supporting new economic development opportunities for the treated produced water outside the oil and gas sector, while maintaining public environmental health and safety. And so those are the two big issues, is trying to reuse as much of the produced water as we can to eliminate or reduce the use of fresh water and create new freshwater sources while being protective of public health and safety and environmental health and safety. And what we're seeing is other states are in the process of doing the same thing. Oklahoma is going to transition to a regulatory structure very similar to what's in New Mexico now in 2021. And Texas is going to transition to a similar regulatory structure in 2022. So we're getting a lot of interest by other states around the country in following what we're doing in New Mexico and how we're going to be able to implement the treatment and reuse of produced water outside oil and gas. So the next slide, if you could go there. I don't have control, so if you guys could do that, that would be great. Here's just the consortium organization. It's really set up as a true consortium with government, university, and industry partners. We include NGOs and state and federal agencies, as well as all the regional universities, New Mexico State, New Mexico Tech, UNM, Colorado School of Mines, UTEP, UT Permian Basin, University of Texas at Austin, Texas Tech. So all of the major universities that surround these, the state of New Mexico, and these transboundary aquifers, if you will, that are being used for produced water. So we have connections with Texas and Oklahoma and Colorado. And so we're trying to include those universities to help us move forward. So the next slide, please. And I think this is the issue that we're going to be having to address, that is going to impact maybe the San Juan and Animas rivers, rivers and watersheds, is how do we utilize this water, treat it in a way that is conducive to public health and safety, as well as maintaining the watersheds. So we do not have the regulations in place, and probably but we'll have those in place, guidance on how to do this testing and evaluation by the end of this year, in October timeframe. We're working with 15 state agencies and 3 or 4 federal agencies to get the right guidance. But these are kind of the general guidelines that we see from around the country, from other states that have tried to utilize non-traditional water resources for applications. And I just wanted to let you know that we're not looking at untreated produced water being used outside oil and gas. And in many cases, they're even looking at use of produced water inside oil and gas, also with some treatment. But in general, here are kind of the water quality levels that will probably be the general criteria. This is not cast in stone yet, but these are some of the things that we're seeing are the ranges that we see across Western states. And you can see the changes from drinking water, aquifer storage and recovery applications, whether we put that in a freshwater aquifer or brackish water aquifer. Agriculture and livestock have different classes of water qualities that are used today. And we'll be looking at those and how those may impact long-term runoff and watershed health, soil health in the San Juan and Animas. Rangeland rehabilitation, there's already been some work been done in the San Juan area on rangeland rehabilitation with treated produced water. Surface water flow augmentation, there's a lot of interest in that down in the Pecos River area, and there's work being done in California and in Pennsylvania right now with treatment of produced water for surface water flow augmentation. There are a lot of minerals in the produced water that have economic value. There's lithium, rare earth metals, other types of heavy metals that could have mineral recovery. There are a few mineral recovery operations in the US currently, and we have them working with us on the consortium to look at where those might be the best opportunity. Other things like road construction and other options also. So I just wanted, this is my last slide. We're in the process of looking at this. We have a consortium of about 140 people, NGOs, government agencies, private concerns, producers, technology companies. So if you're interested in participating, it's open. There are some costs for membership, but they're pretty minor. And you'll have an opportunity to participate with us. We're looking at, the view graph here says October 2020. We have not done any testing yet, but starting in around October, we will start looking at operational testing and research and development testing at some select facilities, and then pilot testing at larger scale beyond that in 2021. So we have a charter through 2022, which is essentially a 3-year charter. And we're really interested in those groups that want to participate and join. We're happy to have you join with us. We've been in operation since around the 1st of January, and it talks about our focus is essentially conducting risk analysis and treatment sampling and conducting pilot tests to make sure we can get cost performance testing and make sure that we can do the risk assessment and toxicology testing to make sure that we do not have any environmental or ecological impacts. So there's the website right there at the bottom of this view graph, and you had my contact information on the first view graph. So if anyone has any questions, I'll take those. If you'd like to contact me about participation in the consortium, feel free to do that too. So thank you very much.
Okay, this is Dennis again. And thank you very much, Mike. We really appreciate the work down there in collaboration with NMED and the other partners in this consortium. So I'm going to give a very quick summary of the conference, and then we'll have the door prize drawings that go back to Mark. But this is the 5th annual conference, and you know the first conference was in 2016, which was the year after the 2015 Gold King mine incident. And you know, right after and during that incident, a lot of the organizations that attend these conferences and others began taking samples and doing studies and began investigating the significance of not just the event itself, but also the long-term impacts of the geologic sources of metals in the watershed and the 100 years of legacy mining in the watershed. And a lot of that information and discoveries was presented at these conferences. So since 2015, there's been some good that's happened. EPA put in a water treatment plant in Gladstone to treat water from the Gold King mine, and that has improved water quality and has also, we think, led to improvements in the ecological health of the river downstream of Silverton, both the benthic macroinvertebrates and the fish. There have also been a number of source control activities at specific mines and tailings piles. EPA designated the Bonita Peak Mining District a Superfund site, also in 2016, and that has led to additional resources being put onto the area, the region, not just Gold King, which is one of a number of mines in that district, a lot of others. There have been interim records of decision that EPA has issued for specific portions of that Superfund site, and a lot of those are seeing or will soon see some type of remediation and source control. So there's good reason to be optimistic about future efforts to control the metals that are going into the watershed and see reduction in risks to human health and the environment. Also in 2016, Congress passed the Wynn Act. This, you may have heard panelists talk about this. This is the Water Infrastructure Improvements for the Nation Act. And it provided $20 million over 5 years. And it goes to EPA, to 3 states and 3 tribes, and 3 regions of EPA. And this has been it's kind of been a career high for me and a lot of other people, because the jurisdictions, these 9 jurisdictions have put some of their best people on this project. You know, Christine Osborn and I know Cheryl Reams has been eavesdropping today. She's an EPA Region 8 who's done a terrific job of kind of guiding, herding cats and guiding 9 jurisdictions, 3 states, 3 tribes, and 3 EPA regions into this watershed scale project of monitoring and management and pushing out information to the public. And early on, one of the decisions that was made by the jurisdictions was to make this holistic across the watersheds, you know, Colorado, New Mexico, Navajo Nation, Utah, as well as making it holistic in terms of water quality. We're not just looking at metals, which are the primary constituents of concern from the mining activities. We're looking at bacteria and nutrients, which can come from human waste, agricultural operations, oil and gas operations, emerging contaminants such as PFAS, pharmaceuticals. And I think that the conference, the 3 days of papers we've had today, really give a good cross-section on the holistic nature of the water issues in this basin, and fits in very well with what we've been doing, you know, in the Wynn Act and with the multi-jurisdictional, multidisciplinary thinking. So let me just talk about very quickly the forum that's later today. The link was posted into the Zoom chat box. It's the Animas Community Forum. Begins at 3 p.m. and runs to 4:30 p.m. I believe you have to register for it separately, but I've been told it's very quick and painless because it's another Zoom event. So anybody who's got the time to attend that is encouraged to do so. I think it's going to be very good. So thanks everybody for attending and participating in this excellent seminar. Thanks to the two Emilys, our tireless sign language interpreters, and many thanks to WRI and to Mark for filling the shoes of Kathy, who retired. You guys are doing a fabulous job. Thank you.
Okay, thank you, Dennis. And yes, I have the link to the Animas River Community Forum where you can view the agenda and get the Zoom access information here. So I'll post, we invite all of our who've taken part in this series to check that out later today. And they'll be going over, talking about things such as the post-416 fire recovery efforts. They'll be giving a tour of their Our Animus online store, Animus Watershed Partnerships New Direction and projects on the Florida River, and updates from various stakeholders working on the Animus watershed. As well, we also encourage our attendees to stick around. Tomorrow, we'll have the last of our Animus and San Juan Watersheds Week activities with a virtual community teach-in. They'll be taking place from 1 to 3 p.m. Mountain Time. Here's a brief overview of what you'll see there. You'll see some presentations from Dr. Carletta Chief, as well as Carmen Lita Chief and Shiprock Chapter President Dwayne Chiliazzi on the social and cultural impacts of the Gold King mine spill on Dene communities located in the San Juan River Valley, as well as flash talks from our conference speakers throughout this webinar series. So we encourage you all to attend that tomorrow. If you've registered for this conference, you should already have the access to that tomorrow. And we'll also be live streaming this through our YouTube channel tomorrow as well.